Good morning. I am Dr.D.Sathya, working as Assistant Professor in Department of Chemistry, SNS College of Technology. Today we are going to discuss one interesting topic, atomic absorption spectroscopy. So, what is meant by atomic absorption? The atomic absorption spectroscopy is nothing but uh, only the metal elements how to the absorb in spectroscopic. That means the electromagnetic radiation interact with the matter. So, the different elements with respect to the unique specific wavelength. So, we know about the interaction of the matter. So, the approximately 75% of earth elements are metals. So, we calculate the metal elements here in atomic absorption spectra. So these techniques forms the foundation of the modern chemical analysis. They enable the precise identification of the elements of the sample. So this is a principle of atomic absorption spectroscopy. The element specific absorption and ground state requirement. Atoms absorb the light at the wavelength unique to each element. So this create the specific absorption fingerprint. And also in ground state requirement, only one atoms in their ground state can absorb the radiation. This makes atomic absorption spectroscopy is highly selective. So the concentration, the absorption directly correlates to the elements concentration. More atoms will be in the greater absorptions. So this is the atomic absorption, the process. What are the process is? For the first one is sample aspiration. So the sample will be in the liquid form. We converted into the aerosol via the nebulizer form. So the fine droplets mix with the fuel is the oxidant gases. The second step is the dissolution. Dissolution means some using the flame, heat from the flame, it's evaporate the solvent. The solvent will be evaporated from the sample, and also the dry sample particles in the flame, it's using for this the second step. The third one is the vaporization. So the particles is converted into the gases, and the dry samples, the particles is converted into the gases. So the temperature is carefully controlled between the 2000 to 3000 range using the ribbon flame design. So the final stage atomization, the gas molecule break down into the free atoms. In whole metal atoms, it's break into the smaller atoms, that means the free atoms. So these ground state atoms then absorb the specific wavelength. So the key components of AAS instrumentation is it's a converted the liquid sample into the atomic vapor. So maybe it's a use the flame or a graphite furnace the technology, and hollow cathode lamp, it's emit the sharp specific lines to the specific target element. So it acts as a radiation source. So the detector is for measure the intensity of the transmitted radiation. It's converted the optical signal. That means the light from signal is converted into the electrical output. So the monochromator already we are discussed in U visible spectra. So the monochromator is part, it isolated the specific wavelength observed by the analyte. That means in beam of light, so the light will be separated from the monochromator. So it eliminates interface from the other wavelength. So hollow cathode lamp is very important in atomic absorption spectroscopy. So the element cathode constructed from the element being analyzed, so create some Frisius spectral lines. So noble gases environment, the filled with the argon or neon gas. Here the argon and neon is the inert gases. That means noble gases like that. So this noble gases, argon and neon, we have to maintain at the low pressure. Gas ionized to create the glow discharge. And the sputtering mechanism, that means the applied voltage causes the gas ions to bombard the cathode. So disloaded of the metal atoms that be emit the light. That means will be ground state metal atom will be emit the light. Excited state atoms already excited, so the remaining part of the metal will be the emit the light. So multi element capability, the specific lamp contain the multiple elements, so allow the detection of the several metals without lamp charges. So this is a detector part, data display and significant application. Photoelectric conversion. In photoelectric conversion, we all know about that the detector form. That means the photons it create the electrical current to the light energy. That means electrical energy is converted into the light energy. So the same process. The photomultiplier to detect the light after it passes through the sample and monochromator. So this is a basic instrumentation part of the AAS. Already we have discussed about the hollow cathode lamp atomizer. This is a nebulizer form. Here the sample and monochromator and detector and recorder. Here in the sample holder, the solution form will be going to the nebulizer and the spray into the flame atomizer. The atomizer dry into the solvent particle, and also the sample will be very dry. And hollow cathode lamp, the monochromator is passed through the flame. So finally we calculate the detector. So AAS is used in different varieties in environmental monitoring and pharmaceutical and mining in lot of industrial applications. So this is the industrial application of AAS, atomic absorption spectroscopy, specific of environmental analysis, clinical and biomedical, food, agriculture and pharma industry. This is assignment questions. I have some reference. Thank you.